Hey, hello everyone. Welcome to my YouTube channel. Myself Omkar. I'm a 2023 graduate. As of now, I work as a full-time software engineer in JP Morgan and Chase. On this channel, I talk about things in tech, software, clearing coding interviews, DSA, system design, and much more. So, to continue our playlist on design pattern, on this video, we will be talking about factory design pattern, which is a type of a creational design pattern. The prerequisite for this is that you must be comfortable in any object-oriented programming language like C++, Java, or Python, and you must be knowing the concepts of the object-oriented programming language. In the last video, we discussed what is singleton pattern. You can check that out if you haven't already. So with that said, let's get started with the factory design pattern. So I have prepared a PPT. We will go through the PPT and understand. Factory design pattern is a creational design pattern that provides an interface for creating object but allows subclass to alter the type of object that will be created. Rather than client directly creating the required object, a factory acts like as an interface in the object creation process. It encapsulates the object creation process, abstracting it from the client code that uses the object. Client doesn't need to know how objects are created, which promotes loose coupling between the classes. Okay, now let's try to make sense. What does it actually means? So what happens is that there is a client and client demands certain type of a service from a service provider. So let's suppose we are the service provider and we have service A, service B with us. We provide the objects, or in other words, the product A, product B. In normal way, what happens is that I will be explaining you in detail example with the code, but with till that point, like we will discuss this ahead in the video, but till that point, have a patience and pay attention to what I'm saying. In normal example, what happens is that we have a client and client opts for a service who provides two types of products, product A and product B. Now, as of now, it's good. But with time, the service provided upgrades his code and adds one more product to it. That is, now it provides the product C as well. Product A, product B, and now the product C has been added. Now that update has been done, but now how will the client know that a new product, that is product C, is also available? The client will not know directly. We need to do changes in the client provided code also. So here we are doing two changes. We are doing changes on our side as we need, but at many number of times we do changes on our side, we need to change client code also, right? Because by changing the client code, then only then the client will know that the new products are available or there is an upgrade in the existing product. So this is because of tight coupling. The client class and the service class are been tightly coupled. So we need to do changes. When one is changed, other one also needs to be changed. So this becomes a problematic in industry where we do frequent upgrades on our service, but you need to change the client code also that many number of times. So to address this comes the factory design. So factory design pattern acts as an interface between the client and between the service provider. So when there are changes into the service class, we will change our interface and we will not touch our client code. So once the client side code is being submitted to the client or is on the client side, we don't need to touch it. If that is working, it's good enough. We have our upgrades done in our service provider. We change our interface, that is OS factory, on our side. The clients need not to do anything. Let's understand it with an example. But before that, it is important that we thoroughly know the concept of encapsulation and abstraction. As I have mentioned in the third paragraph, it encapsulates the object creation process, abstracting it from the client code that uses the object. Client doesn't need to know how objects are created, which promotes loose coupling between the classes. Let's understand this first as a prerequisite. Okay, encapsulation versus abstraction. So encapsulation is the concept of bundling data variables and the method functions that operate on the data into a single unit known as class. This unit controls access to its data, allowing you to hide the internal details and protect the data from unauthorized changes. So what does this mean? Means like, see, there is a class and it has some data types or some variables into it and associated functions in it. All of them are bundled inside one particular class. This concept is equals to encapsulation. Let's understand it by an example. So here we have our bank account class. Here we have a private variable called as a balance and associated functions in it. As we have bank account, what can we do with the bank account? We can withdraw the amount, we can deposit the amount, and we can check our bank balance. So these are the required functions. Like we can only withdraw the account if the amount is greater than zero. We can withdraw the amount only if the requested amount is greater than zero and less than equal to the available balance, and we will subtract the amount from the balance. Now, as you can see here, the data type balance is private and it can be only accessed by the class functions. So this is what encapsulation actually means. We have bundled together the data type and the associated functions inside one single class called as a bank account. Okay, so this is what encapsulation is. Now let's understand what is abstraction. Abstraction is a process of simplifying complex systems by breaking them into smaller, manageable parts and focusing on the essential details while hiding unnecessary complexities. In programming, abstraction allows you to create classes with clear and simple interface while the implementation details are hidden. Okay, so I will explain what is abstraction now. There is one class, okay, it's a complex class. There is one another class B, class A, class B, it is of another complex type. Now we want to access the class A and class B. Both have some similarities in between them. Both can be derived from some parent class. So that class is like a layer of abstraction for the class A and the class B. As it says, we are doing, we are simplifying complex systems by breaking them into smaller, manageable parts and focusing on the essential details. Okay, let's understand by example. So abstraction. So here I have three classes. Once there is a shape, which is a pure interface, as you can see, this is a way in C++ where you create pure virtual functions, virtual, double, area equal to zero, equal to function. That means it is a pure virtual function that makes it an abstract class. I have two classes, circle and square, which are derived respectively from shape, as you can see. And then we have this area function implemented. For circle, the area will be 3.14 into radius, while for the square it will be side square. Okay, ठीक है. So here, as I provided the example, once on one side there is a class square, on other side there is a class circle. So both are belong to the same category. Both belong to the category of shape. On one side there is a circle, on other side there is a square. There is a on one side there is a circle, on other side there is a square. We create a layer of abstraction, that is a layer of shape. Which shape I can point to the circle also, because circle is a type of shape. With this circle shape I can point to the square also, because square is a type of shape. Okay, so that is what abstraction actually means. Like it's like creating a layer on top of complex layers, complex classes. So as you can see here, like, to cut down the real life scenario, like I have made it very short. Here square is like a complex object. It has its own implementation of area function, because the area way of calculating the area of square is different from the way of calculating the area of circle. So circle has its own different implementation of area. But the shape, here the shape has the area function, which can be applied to the circle also and to the square also. So shape here acts as a layer of extra abstraction. So with that said, I have explained you what is encapsulation, what is abstraction. Let's go ahead. Okay. It promotes code usability by centralizing the object creation logic in a single place. This makes it easier to make changes or extensions to the object creation process without modifying the client code. As I said, without modifying the client code. It allows you to introduce new types of objects or variants without modifying existing code. So the solo purpose of the factory design pattern is that it gives you the more flexibility. It introduces loose coupling. Now, as you can see, whenever our service provider or the object provider code is modified, we don't need to modify the client code. This is an example of loose coupling. Now, the client class and the service provider class are loosely coupled. So this changes, we don't need to touch this. We just change the interface in between, that is the factory. Okay. So this is the pictorial representation of what I said. Client, what was happening first? First, client was directly talking to the object creation that I need a specific type of object. I need object A, I need object B, I need object C. An object creation class was providing it to the client. But any changes in the object creation class, I add object D. We need to update the client code also. That it allows the creation of object D. So that is being updated into the client code. So to get over this, we introduce the factory. Factory is an interface between the two classes. Now, whenever there is a change in the object creation, we just change our interface in between, that is the factory. We don't touch our client. Let's understand it via an example. So as you can see, I have here two classes, client and OS. Here my service is the OS service. I am here the OS provider. I provide three types of OS. I provide Android, I provide iOS, and I provide Windows. Okay, I will explain you this class. So here basically I have my class OS, which here is a pure abstract class. You can see here pure virtual function, virtual void, create OS equal to 0. Android derives from the OS, iOS is also derived from the OS, and Windows is also derived from the OS. Both have a concrete implementation of create OS function. Here, as you can see, Android OS created, iOS OS created, and Windows OS created respectively. So, and here I have my client code. What does the client code do? Firstly, basically I have included respective headers. After that, here I have my one reference variable created for the operating system. Here I ask the input from these three from the user, Android, iOS, or Windows, which kind of OS he actually wants. We take the OS type as an input as a string, and then we compare. If it is an Android OS, create the Android OS object. If it is an iOS OS, then create iOS OS object. If it is a Windows OS, then you respectively create the Windows OS. If it anything else, then you just return 0 by giving the message like enter some valid OS. Let's run this program. So I click on run button. So as you can see, it spits out three options. I enter Android. I get Android OS created. Let's do it one more time with iOS, iOS OS created. Okay. Now, as I said, I was the OS provider. Now, what I do is that I change here. I decide to provide Linux services also. So now what I will do, I will add Linux class also. Linux, which is publicly derived from OS. So public function here, void create OS. What does it do? It's control out Linux OS created. Okay, okay. So I saved it. Now, will this code work? On my client side, I don't have an else if statement to access the new OS or new object that is Linux. I need to change the client code also. So here there is a problem, right? So I need to manually change my client code also. I need to add here sorry, OS type is equal to Linux. If the user gives the Linux as the OS type, then you create operating system equal to new Linux. And as the type of products have increased, I need to add here also that now I have fourth type of product, which is Linux. Okay, okay. I will save this. Control S save. And now if I run the code, see, I got the fourth option OS and I enter Linux, that Linux OS created. Okay. So as you saw the practical implementation and what actually happens, if the service provider, that is OS provider, changes, we need to modify the client code also. So we need to change this. Client code must not be touched. Once we submit the client code to the client, it must remain untouched. We must loosely couple the client class and the service provider class. So that loose coupling occurs how? It offers through an interface, which is our factory. So here I have my OS factory created. I have same OS class, service provider class. This doesn't change. I have smart client and OS factory. Okay. First, let's understand what is OS factory. As I said, OS factory is a type of interface. Here I have two functions. Get OS types basically use what type of services I'm offering. So here I have these three types of services as of now: Android, iOS, and Windows. And next I have this logic implemented here, where factory provides the respective product depending on what input is been passed. So here I have OS type as a string. Here initially I have operating system as my reference variable, which is initially null. If the string is Android, create an Android object. If the string is iOS, create an iOS object. If the string is Windows, create an Windows object. And if it is anything else, then we will output our message, enter a valid OS. Then we return that reference variable. So was our factory. And next go to our smart client. Now our smart client doesn't directly talk to the OS provider. We talk to a factory. For that, we create first our factory. Here OSF is my OS factory. Then enter the type of OS you want. So we will ask factory that what kind of OS do we have. So this get OS types function in the factory will return this string and it will be printed on the console. Then I have OS type. I will take the user input OS type and then operating system equals to get OS type. So I will pass that string as an input to get OS function, which in return will be returning me the type of operating system that I want, that the user wants, and I will create that operating system. So as you can see, you saw here, get OS returns me that respective operating system by creating the operating system. Okay, okay. Now again, same thing. Let's run this as well. First, I go to the smart client. I will first clear the terminal. Clear. Okay. Now let's run our smart client. Okay. I again enter here Android and Android is created. So far, so good. Now I had new OS here in the OS tab. As you can see, we have already added Linux. Now I will not at all touch the smart client. As you can see, I will change the OS factory. Here I will add our fourth new product, that is Linux \n, and here also I will add now new product object if OS type is equal to Linux. Then operating system equal to new Linux. That's it. I will save it. Control S. And now we are good to go. As you see, I not even touched the smart client code. I changed my interface. I changed my OS factory. Now, after we have saved it, let's run this program. So we have our new product Linux, as we can see here. Now let's enter Linux and Linux OS created. So here at the beginning of this, I have my OS factory.cpp included into the header. So yeah, we have successfully implemented factory design. So again, I will repeat, like I will summarize what I have told in this video. So on one side there is a client, on other side there is a service provider. So service provider provides the service objects as the client demands. Service initially it was when the both the classes were tightly coupled. If this changes, we need to change this also. If new products are added to this, we need to make appropriate changes on the client side also. But now this is problematic. As many times the service provider changes, we need to disturb our client that please change your code to in appropriate to the new service class. So now we loosely couple. In loose coupling, what does happen? We introduce new interface, which was a factory. Now factory talks to the service provider, client talks to the factory, factory talks to the service provider. If anything changes in the service, we change the factory, we don't touch the client. So yeah, this is happening because of factory design pattern. So that's all from my side. Thank you for watching.